Over the past year, RAG has become one of the hottest techniques in AI. Companies are using it to power customer support chatbots, legal research assistants, financial analysis tools, and more. But most people are only familiar with the basics. You take a user's question, you retrieve some documents from a knowledge base, and you pass both the question and those documents into a language model. That's RAG, Retrieval Augmented Generation. It grounds the model's answers in external knowledge instead of relying only on what the model was trained on. Hello everyone, welcome on Debugging with K Tips. If it is not your first time here, then welcome back. I am glad to have you here. Now, what happens when you need more than just a simple question and answer system? What if your use case requires reasoning across multiple steps, deciding whether or not retrieval is necessary, or even combining different tools like APIs and databases? That's where RAG agents come in. An agent is a system that doesn't just respond, it thinks. It can plan, it can decide, and it can execute multiple steps to reach the right answer. If RAG is like giving your model a library card, a RAG agent is like hiring a research assistant who knows when to go to the library, which shelves to check, how to cross-check sources, and when to stop digging. Now, here's the challenge. Building a RAG agent is a lot more complex than building a RAG app. If you just jump in and start coding, you'll run into problems with accuracy, hallucination, cost, and user trust. That's why before I build any RAG agent, I ask myself a set of key questions. These questions act like a checklist. They help me design the system in a way that is reliable, useful, and scalable. And in this video, I want to walk you through those questions, step by step, with real-world examples, so you can see how they play out. The first set of questions is about problem framing. I start by asking, what real problem am I solving? Do I actually need an agent here? For example, if I just want to build a customer support chatbot that answers product FAQs, I don't need a RAG agent. A simple retrieval pipeline will do the job. But if I want to build a healthcare assistant that helps doctors review patient history, cross-reference medical guidelines, and suggest next steps, then an agent makes sense, because the system needs to plan and reason across multiple sources. The second framing question is RAG the right tool at all? If I'm building a recommendation system for e-commerce, fine-tuning on purchase history might be better. If I'm searching logs for cybersecurity threats, a specialized search engine may outperform RAG. Don't force RAG into problems it wasn't designed to solve. Once the problem is clear, I move to data and retrieval. I ask, what knowledge sources will my agent need? Am I pulling from PDFs, APIs, spreadsheets, or live databases? Let's take a financial example. If I'm building a tool for analysts, my sources might include company filings, earnings call transcripts, and stock market APIs. Then I think about chunking. How do I break these sources into retrievable units? For financial filings, I might chunk by section, balance sheet, income statement, risk disclosures. For legal contracts, I might chunk by clauses. For research papers, by sections or abstracts. Too big, and the model drowns in irrelevant text. Too small, and it loses context. Then I ask, what retrieval method is right for me? Pure vector search is useful, but often not enough. Hybrid search, which combines embeddings with keyword and metadata filters, is usually better. In a legal research agent, I might search semantically for similar cases but also filter by jurisdiction and year. In a healthcare agent, I might search for semantically related treatment guidelines but filter by condition or patient demographic. Hybrid retrieval balances breadth and precision. The third set of questions is about reasoning and planning. A RAG agent isn't just about finding documents. It needs to make decisions. So I ask, how will my agent break down complex queries into smaller steps? For example, imagine a compliance officer asking, summarize the new European data privacy regulations and explain how they differ from last year's version. That's not one retrieval, it's two, the old law, the new law, and then a comparison step. That requires planning. I also ask, when should the agent retrieve, and when should it rely on what it already knows? In a customer service chatbot, if a user asks, "Where's my order?" the agent shouldn't retrieve product manuals. It should call the order tracking API instead. Smart agents don't just retrieve for every query, they choose the right action. Next is prompting and reliability. Here I ask, how do I structure prompts so the agent uses retrieved context properly? The danger here is hallucination. If the prompt isn't clear, the model may invent facts. A strong prompt makes it explicit: use only the retrieved context, cite your sources, and if the answer isn't in the context, say so. Imagine a healthcare assistant giving a doctor advice. If the system hallucinates a treatment, that's dangerous. Reliability isn't optional. Another question is, how will I detect unsupported claims? For example, in a financial analysis tool, if the agent claims a company had a revenue drop last quarter, I need to ensure that statement actually appears in the earnings report. Validating outputs against retrieved evidence is key. Then I think about user experience, security, and scaling. Do my users just want the answer, or do they want to see citations, source documents, and reasoning steps? In legal or healthcare applications, transparency is critical. Users need to see exactly where the answer came from. On the security side, I ask, how do I handle sensitive data? If I'm embedding internal HR documents, those embeddings might contain confidential information. Am I storing them securely? Do I need role-based access controls so employees only see what they're authorized to see? And for scaling, how do I keep the system fast and affordable? That means caching frequent queries, monitoring token usage, and building efficient pipelines so latency doesn't frustrate users. Finally, there's continuous improvement. A RAG agent is not something you build once and forget. Your data changes, your users evolve, and your system must adapt. So I ask, how will I evaluate performance over time? In customer support, am I tracking whether answers resolve the issue? In legal research, am I checking whether the retrieved cases are actually relevant? Am I collecting user feedback, like thumbs up and thumbs down, to refine the system? And how often do I refresh my embeddings, rechunk my documents, or adjust my prompts? The best RAG agents get smarter with time. When you put all these questions together, they form a practical design framework. And there's one meta question that ties everything together. If this RAG agent were a human researcher, would I trust the way it looks up information, reasons through it, and explains the answer? If the answer is no, you're not done yet. So, if you're working on RAG agents, think about these questions as you design your system. They'll save you from a lot of painful mistakes down the road. And I'd love to hear from you. What's the biggest challenge you're facing right now? Is it retrieval, reliability, or scaling? Drop it in the comments and let's talk about it. And if this breakdown was helpful, hit like and subscribe for more deep dives into AI. Happy coding and debugging with K-Tips. See you in the next one.